Today we're going to learn a few more differentiation patterns, and specifically is what we'll talk about are the derivatives of our six trig functions. We already have two of them though. We'll also talk about the derivative of e to the x, and we'll look at taking maybe second derivatives and third derivatives and so on. So first let's start off here with tangent of x. This is one of the trig functions that we don't know how to take its derivative yet. Now, we will have a nice little formula for it, but we can actually come up with that formula on our own. Let's see what it is. So if we're going to take the derivative of f up here, it might actually be helpful to do some preliminary steps. Maybe this tangent of x, we could maybe rewrite it a little bit different, maybe in terms of some functions that we already know the derivatives of. And so to show you what I mean, this is what I mean. We could rewrite this tangent here as sine of x over cosine of x. And so what this means is if we want to take the derivative of tangent of x, we can just use the quotient rule and differentiate this. Okay. Let's go ahead and do that. I'm going to make a little more room. There we go. So the derivative of sine is cosine. Okay. And then if we were to multiply by the bottom function, that would be also cosine of x. And then we want minus, and then the first function, sine of x. And then times the derivative of the bottom function here. If we take the derivative of that, that's minus sine of x. And then this is all over cosine of x squared. All right, let's see if we can go a little further with this. So cosine of x times cosine of x is cosine squared of x. And sine of x, or actually we have a double negative here. Let's take care of that first. So this is now addition. And then we have sine of x times sine of x, which is sine squared of x. And this is all over cosine squared of x. And some of you might remember from maybe trigonometry or pre-calc that cosine squared of x plus sine squared of x is equal to 1. And this is all over cosine squared of x. And by the way, we're done differentiating. This was our derivative right here. We're just simplifying this. Okay. So let's go another step. Well, 1 over cosine of x is secant of x. And so since this is squared, is what we have is secant squared of x. Okay. And so the four trig functions that we hadn't seen their derivatives of before today can all be found using the same technique. We can use the quotient rule. Let's go ahead and write down what all these derivatives are. Okay. So again, we already have some of these. For instance, the derivative of sine is cosine of x. And the derivative of cosine of x is minus sine of x. And then we have the derivative with respect to x of tangent of x, and we already found that one. It was secant squared. And the derivative of cotangent of x is minus cosecant squared of x. And then our last pair down here, the derivative of secant of x is secant of x tangent of x. And the derivative with respect to x of cosecant of x is minus cosecant of x cotangent of x. All right, now these top two you probably will not forget here. Okay, you're going to use them enough to where you probably won't have to spend much time trying to memorize those two. But the remaining four, if you notice one thing, it is that the derivatives for tangent and secant look just like the ones for cotangent and cosecant. It's just we're using these co-functions. We have cosecant squared here and cosecant cotangent in the bottom formula. Okay. And other than these co-functions being in here, the other difference is a sign. Okay. And so really, if you can remember these two in the bottom left, okay, that I have bracketed off here, then these second two follow pretty easily. Okay? Again, just noting that instead of secant squared, it's cosecant squared, and then with a negative. And instead of secant tangent, it's minus cosecant cotangent. All right, and we have another example here. And here, all we're doing is trying to find the equation of the tangent line to y equals secant of x at x equals pi over 3. So remember, we want to use this little formula here. Maybe I'll write m in here this time, and x minus x1. Okay. And so x1 for us is this pi over 3. Okay. And then if we want to find y1, all we need to do is plug this pi over 3 into the function. So this is really just y of pi over 3, which is really just secant of pi over 3. And so if we're trying to find secant of pi over 3, you might remember, well, this is, right, 1 over cosine of pi over 3. And cosine of pi over 3 is 1/2. So we have 1 over 1/2, which is 2. So we have x1, we now have y1. The only other thing we have left is to find the derivative. That way we can figure out what m is. So let's see here. I will, I suppose, squeeze this in right here. So we have y equals secant of x. And if we want to take its derivative, we know that should be secant of x tangent of x. And so if we were to then try and find the slope, well, then is what we want is the derivative at pi over 3. Right? We want the slope of the tangent line at x equals pi over 3. And so this is equivalent to just secant of pi over 3 times tangent of pi over 3. And we just found secant of pi over 3, it was 2. And if we were to find tangent of pi over 3, remember that this is sine of pi over 3 over cosine of pi over 3. Okay, and so sine of pi over 3 is the square root of 3 over 2. And cosine of pi over 3 is 1/2. And so if we simplify this, we just end up with a 2 here still, and then times the square root of 3. All right. And now we can finally write the equation. Okay. So that equation should look like y minus y1, which we found to be 2, is equal to m, which we found was 2 times the square root of 3, and then times x minus x1, and x1 was pi over 3. And so if it was on a test, you could leave your answer like this. If we're doing the online homework, you will need to solve for y, but that's just a little bit of algebra there. And our next topic is the derivative of e to the x. Okay. And this is going to be one of your favorite derivatives because it's so simple. Okay. And what we're going to do is we're going to switch over to Desmos right now and look at the graph of some functions and their derivatives and then compare that to the graph of e to the x and its derivative.